So let us go to the next topic, that is the relation between current I and current density J bar. Okay, current I and current density J bar. So to observe the relation between current I and current density J bar, first we need to revise the definitions of current and current density again. So what is meant by general electric current? General current is defined as the rate of flow of charge at a specified point, or the amount of charge passing per unit time through a conductor at a specified point is called as electric current. That means I equal to dq by dt. The rate of flow of charge in a conductor at a specified point is called as electric current, or it can be also defined as the amount of charge per unit time at a specified point in a conductor is called as electric current. Okay. So this is called electric current I, which is expressed in coulombs per second or amperes. What about the current density J bar? J bar is defined as, actually J bar is expressed in vector form. But if we consider only magnitude, what is this current density J? Current density J is given as the current flowing in a conductor per unit surface area. The current flowing in a conductor per unit surface area is called as, that means the current flowing in a conductor per unit surface area is called as current density J. This is the magnitude, and if you express this in vector form, then you should keep bar, J bar. So I is amperes, area means meter square, ampere per meter square. So we have known what is meant by current and what is meant by current density J bar in vector form. Now we need to derive a relation between I and J bar. For deriving the relation between I and J bar, we generally know what is meant by current. We have introduced a new term called as current density. Current density means current per unit area. Current flowing through unit surface area is called as current density J bar. So for that, let us take a surface, because we have defined this current density as current flowing through unit surface area. So consider a surface area. This is some surface you are considering. Okay. So how we have defined the direction of current during this current density? The current should be always perpendicular to the plane or surface that you are considering. In the definition only we have defined that. So you should take the direction of current as perpendicular to the plane. Now, always while deriving any relation, instead of considering the whole surface area, we will take only a small differential surface ds. Small differential surface ds is only considered. This is the complete surface area, and this is a small differential surface area ds. Okay, and the unit vector that is perpendicular to this is an bar. The unit vector that is perpendicular to this differential surface ds is an bar, and your I is perpendicular to the plane that you are considering, surface that you are considering, and your J bar will be also in the direction of I only, because current per unit surface area is called as current density J bar. So I and J bar will be perpendicular to the surface. If your ds, this differential surface area ds has a unit vector perpendicular to it, that is an bar. So how to express J bar? J bar is its magnitude J into what is the unit vector an bar. How to express differential surface ds in vector form? ds is actually in this plane, but ds bar is a vector which is perpendicular to ds. Okay, that we have already discussed in coordinate systems. ds is a differential surface which is in xy plane, but ds bar is a vector which is perpendicular to the ds. That means its magnitude ds into what is the unit vector that is perpendicular to the ds, an bar. Okay, now take the dot product for this. Take the dot product for this. Why we are taking dot product means I bar, J bar, DS bar all are mutually parallel to each other. See, if you consider I bar, J bar, just they are perpendicular to the surface, and I bar, J bar, DS bar, all these are parallel to each other. For that it is convenient to apply dot product. If you take theta 90, then it will become 0. So we can't take theta 90. Your I bar and J bar is like this, and your DS bar is also like this. All these are parallel to each other, and these vectors are perpendicular to the surface that you are considering. So what is the angle between I bar and J bar? 0. Both are parallel to each other. What is the angle between J bar and DS bar? That is also 0, because both are parallel to each other. So you can apply dot product. So if you apply dot product, what is J bar? J into AN bar dot, what is DS bar? DS into AN bar. So what is AN bar dot AN bar? That is equal to 1. AN bar dot AN bar is equal to 1. So J bar dot DS bar is equal to J DS. J DS. Okay. J bar dot DS bar is equal to J DS. This is the relation that you are obtaining. Then we know that current density J bar is given as the ratio of current and the surface area. Current flowing through unit surface area is called as current density J bar in vector form. So from this, what is the current I? Current I is J bar into A surface area. This A is nothing but surface area. So if you consider J into surface area, J into surface area will give you the current or not? It is nothing but equal to current only. But you are considering only a differential surface area. So you will get a current which is differential current dI, because I equal to J into surface area. J into surface area will give you a current, but you are taking differential surface area, so it is a differential current. Okay. So that dI is equal to JDS. If you want the total current, then you integrate on both sides. On integrating both sides, that integration and derivative will be cancelled. Then I is equal to integral J ds. That means this is the surface integral. As you are considering a surface area, so surface integral of J ds. Okay. Now this formula is valid. When your current direction is at right angles to the plane surface area that you are considering. When your current direction is not perpendicular to the plane that you are considering, always it is not possible that this current should be perpendicular to the surface that you are considering. If at all the current I is perpendicular to the surface that you are considering, then you can express this formula I equal to surface integral of J ds. But there are some cases so it is not compulsory that always your current direction should be perpendicular to the surface that you are considering. Always it is not possible. There are some cases when your current direction and J bar, current density direction, is not perpendicular to the plane that you are considering. This is the case. It is making some angle theta with the surface that you are considering. That means if this is your surface, this is making some angle theta. Okay. Then if you consider a small differential surface, ds, then the unit vector that is perpendicular to this ds is an bar. For these cases, when your current and current density direction are not perpendicular to the plane that you are considering. That means surface area that you are considering, but they are making some angle theta with the surface area or plane you are considering. In this case, we can't use this formula directly. This formula is used when current is perpendicular to the plane that you are considering. But what about this case? When current and current density are not perpendicular to the surface area, they are making some angle theta with the plane that you are considering. For this case, your current is expressed as I equal to closed surface integral of j bar dot ds bar. Just we can leave like that. So I equal to closed surface integral of integral j bar dot ds bar. Here why we are leaving this dot product like this means, actually if you consider the first case, the angle between I bar, j bar, all these are zeros only, because you are considering that the I and j are perpendicular to the surface area. So the angle between I, j and ds bar all are zeros. So directly if you take the dot product, what is a bar dot b bar? Mod a mod b cos theta. Mod a bar mod b bar cos theta, if you substitute 0, then you will get simple a b, that's all. So if it is at right angles, then the formula is very simple. But if the current direction is not at right angles to the plane that you are considering, then you can't substitute theta equal to 0 as you are substituting here. So leave the dot product like that only. After knowing that angle, you can solve this dot product. So simply you can express the current I in this case as I equal to closed surface integral of j bar dot ds bar. This is the relation between I and j bar. I equal to closed surface integral of j bar dot ds bar, which is the relation between I and j bar. Okay, which is very important. I equal to closed surface integral of j bar dot ds bar. You should remember that.